All right, so section 11.3 is about combinations. The number of possible combinations if R items are taken from N items is N choose R of N factorial divided by N minus R factorial times R factorial. So N factorial divided by N minus R factorial times R factorial. So they look very similar. What's the difference between the permutation and the combination formulas? Yeah, the one more step, the one more R factorial on the bottom. Keep that in mind. The R factorial on the bottom. So our biggest thing here, biggest takeaway, maybe I should have highlighted it before, was that for a combination is when the order does not matter. So before we were doing with, okay, what is your order of the comedians going on stage? What was the order of president, vice president, secretary, treasurer, all that stuff? So now we're doing where order does not matter. So starting off by, let's just kind of play with this formula this time. We have 14 items, and we're choosing from that 14, 13 of them. So in our calculators, or let's do it, can you just amuse me and do it longhand one time? Just one time. So N choosing R items. Out of 14, we're choosing 13. So in our calculator, or in our formula, we have 14 items, so 14 factorial divided by 14 minus 13 factorial times 13 factorial. So wherever we see an N, we're going to plug in 14. Wherever we see an R, we're going to plug in 13. So in our calculators, we have 14 factorial divided by, everything's on the bottom, so everything needs to go in parentheses to group it to go on the bottom. We have another parentheses, 14 minus 13, closing that out, factorial, times 13 factorial, closing out that parentheses to group everything on the bottom. So if you have a graphing calculator, it should look exactly the same. You just have to go through another step to get your factorials. So we should get 14. 14. Do we agree? Do we need to see that again? Questions for me? Yes, because I have to group all of this stuff on the bottom. So I use a parenthesis to group everything on the bottom. Then I use another parenthesis to group my 14 minus 13 together. Times 13 factorial, and then my last parenthesis. Do I need to do it one more time? Okay, so let's do it again. So 14 factorial divided by our parentheses to group everything on the bottom, which is this green one. Another parentheses to group 14 minus 13, closing that parentheses. So that's our first, or the one that we closed from this one. Factorial times 13 factorial, and then closing the second bracket, which was the green one on our paper. Yep. And then we should get 14. Thank you. What else? So we know, just like permutations, combinations, it already has the formula for us in here. So we can plug in 14, because that's our left number. That's the number we're choosing from. We have 14 items. We're choosing, so combination. So PRB. The second one over says combination. So click that one. We have 14 items and we're choosing 13. Press enter. Boom. Done. So our calculator is very helpful if we know how to use it. And now you know what the PRB button means. Everyone's always like, oh, what does that even mean? Brings up probability stuff. All right. Don't laugh at me. Okay. So same thing, if we have 12 items and we're choosing 12 of them in a combination, so 12, PRB, going over to combination. That was a little fast, sorry. We're choosing out of the 12 things. 1, done. Which that makes sense if we put this into our formula. We have 12 factorial divided by 12 minus 12 factorial times 12 factorial. So order of operations tells us to do whatever's inside the parentheses first. So I have 12 factorial. 12 minus 12 is 0 factorial times 12 factorial. My 12 factorials cancel out. I'm left over with 1 over 0 factorial. We said 0 factorial was 1, so we're left over with 1. So if you were just wondering how we got that, that's how it happens. Or you just plug it into your calculator, it'll tell you it's 1 done.
So if they're both the same number, it's automatically going to be 1.
Bingo. So they're both the same number, whether they're both going to be 1. If we have 12 items and I'm choosing 12 of them out, so if we have 12 stress balls and I'm taking all 12 of them out, there's only one option. It doesn't matter what the order is. There's only one combination of them. Taking them all out. So same concept. If we have 5 stress balls and we're choosing 0 of them, how many ways can we do that? Just one way. Let's make sure. 5, PRB, scrolling over to our combination. We're choosing 0 items out of the 5. Only one way to do that. Just not take anything out. So what's 1? That's it. How could I help you so far? So that's calculator stuff. So now we're actually going to try to use it. So for example, an election ballot asks voters to select 5 city commissioners from a group of 12 candidates. And how many ways can this be done? So they're just choosing 5, did I say county? I don't know. Anyways, we're just choosing 5 commissioners. Doesn't matter what, they're still going to be commissioners, so it doesn't matter what order. So we're going to use a combination. So out of how many are there to be chosen? How many are there total? 12. How many are we choosing? 5. So there's 12 total. We're choosing 5. So in our calculator, 12. Hitting our PRB button, scrolling over to combination tool. We're choosing 5 of them. There's 729 different ways to do so. Do we agree? 729? What? I'm getting dyslexic, sorry. I don't even know. What did I say? 729. Oh. Ooh. 792. Thank you. I was like, I think I put that in, right? I don't even catch that I'm saying it. Last one. A person has 4 dress shirts, 3 ties, and 6 jackets. And how many ways can that person select a dress, a shirt, and a tie, and a jacket, a dress, shirt? Never mind. For work today. Losing it. Okay, so going back. Okay, so if we have a dress shirt, is that like a t-shirt dress? Does that count? Okay, so how many different options do they have for shirts to pick? 4 different options. How many different ties do they have?
3.
How many different jackets?
6.
What about their pants? Weird. 6. So how many different options do we have here? 72, thank you. 4 times 3 times 6 will give us 72 different options. So that's 4-3 combination.